Hello and welcome. I'm Bill Wake. We're working on an evolutionary design approach to replacing a parser in the basic interpreter we developed a few weeks ago. We got through, I don't know, a third to half of the expressions. I'm hoping to finish the expressions this session and maybe start statements. I can't do a session tomorrow, so normally I would do this on Friday. I will be back Monday the 18th. If possible, I'm going to squeeze in a session this afternoon starting 2 p.m. EDT or 7 p.m. UTC. We'll see how that goes. All right. Let's see. We did some work on expressions, and the big takeaway here is expressions are mutually recursive. So expression eventually gets down to factor, which goes to parenthesized expression, which goes back to expression. And variable, predefined function call, user-defined function call, these all also reference expression. So this is the reason we need wrappers that go both from call old or call new. So that's where we're at there. We started on parenthesized expression the other day. So I think we've got everything from expression down to power done. But we haven't done factor. So we started parenthesized expression. We'll go ahead and finish what we can there and hopefully wrap that up. If we do, we'll skip into statements, which have their own issues, and we'll come back to that. Okay, so parenthesized expression. We put together a parser that matches the parentheses and an expression inside, and we call it. So I think, let's make sure everything's running, but I believe we left it in good shape. Okay, good. A little more volume there. Let's inline this. I don't think there's any other references other than it's one call. Yep. Okay, so let's take this. Unfortunately, I don't have an inline in the tool, but we can move parenthesized parser's definition up, and this will replace this. Oops. Okay, and this will no longer be needed. Okay, so we inline.
Did you order this today? Or what time?
Sorry about that. Okay, let's go ahead and push that. All right. Let's see, back up here. Okay. We've got the parenthesized expression. Let's deal with numeric factor. That looks called twice. Okay, so basically this is converting the token's float value to an expression. So let's define. Well, the case for this is well, let's say number parser equals match dot number, and that doesn't produce an expression, that produces a token. So we need a function that converts a token to an expression, a token whose value is a float value. Okay. Let's see. And I guess we'll call it make number. So function make number. Its argument is a token, and its result is an expression. Okay, so I'm just kind of redoing this one, and we'll just return expression.number with token.float. Okay, and we can call that here. Okay. Then this one is similar, integer parser. There's a little tension in our system between integer and number. Most places in BASIC, for computing variables, they're all floating point. You do have things like line numbers that are integers and array sizes. And there are a few functions that kind of promise to return you integers. But yeah, that's kind of the exception. Okay. So this one is going to be the same as this one. Try wrap new number parser. And this is the same. All right. Return type expression. Why not? Oops. Pipe. It should return an expression. This one returns an expression because the expression returns a capital expression. To return type expression. That doesn't sound right to me. Wrap new pipe expression. Okay. Pipe satisfy token expression. Where's another example of pipe? Up here. Pipe to simple statement. Let's get an expression one. Make binary expression. It's a argument from some type to an expression. Maybe match isn't doing what I'm thinking. Just do a little compiler test here. Satisfy token. Well, I would think that produces a token. Wrap yourself. Oh, dot parse. Ugh. Can I actually call it? Whoops. Yeah, let's go back. Integer parser, wrap new. Integer parser. Okay, let's take this out. Does anybody call this now? No. All right. Make factor handle number and integer. Okay. Number token number integer. Okay, string is pretty much the same. We'll need a make integer parser or make string. match string. I don't know, that's almost simple enough. You know, I'm gonna do one thing at a time. That's what I'm gonna do. But in this case, I'm going to inline this function. Okay, so $0 is a token, and we just want to do dot string of $0 dot string bang. Okay. Expression dot string. Okay, that's integer parser. How about string parser? Okay, in this case, let's take this. Okay. Now, I think this is simple enough. We can do the same thing. Token.float is $0. Nope, not enough. Okay. I wish that would infer it, but okay. All right, so we got the string. Okay, variable predefined function and user defined function. Okay. They're, I guess let's just tackle them one at a time. Oh, where am I? All green. Okay, numeric string constants are done. Okay, left parent and variable. Okay, now this thing, the token is a variable. All right, so what we're gonna do, we gotta match variable. Variable parser equals, okay, we match variable. Okay, now this bit, type name.last is $, then the type is string or number. Okay, well, let's not worry about that just yet. Okay, if token type is not left paren. Oh, interesting. Okay, this is Okay, so basically, this is the case for a variable optionally followed by um, parentheses. Basically, it's either a variable or an array reference. And we need to, if it's just a variable, we'll return that. Otherwise, we're building up a list of expressions and doing that. Okay, and I actually feel like this should go down a line. Not that it matters since we're trying to get rid of it, but there you go. Okay. So if you get this far, you've matched a variable, and that's fine. But if you should happen to have a left parenthesis, let's maybe do this like this. Okay. If you match dot left parend, which we can ignore. I mean, it's there for grouping, but it's not a token we need to see. Okay, so if you find missing a left parend, okay, and I think our message will need to accommodate that. Okay, otherwise, we're doing a comma list of expressions. Okay, so left parend, okay, and then we want to see expression. Well, we have to do a RAPLed self expression, and then separated by commas, and then a right parend. Match right parend. Okay. Does that look right? Match variable and an optional left parend expression with comma. I guess we could put these, indent this and indent this like that. Yeah, I think that helps. Okay, so match variable, and then optionally we get a left parend, a bunch of expressions separated by commas that we ignore the commas, and a right parend. Okay, and all that should do the matching. That gets caught, but then we have to do the production of this. Okay, and I don't know. This is like make variable or array. Make variable or array reference. Okay, I think we'll let that be. All right, and now this function. All right, we had to kind of decode what this produces. So it certainly produces a token. Func make variable or array. Okay, and the argument is a token. Okay, and so it's a tuple, the token, and then this optional. So the optional, well, we throw away the left parens. All we have is the repeated expressions. So this is array of expression optional. Variable parser never used. Okay. And it produces an expression. Okay. And everything's happy here. Oh, okay. No return. Yeah. Well, let's just return dot missing. Okay. And make sure that builds. Yep. Okay. So I got the types right. All right. And now we have to basically pull out the semantics of this stuff. Okay. So I'm going to copy that little bit. And this is more for inspiration. And again, I'm in this position. It's weird to me. I'm not test driving this stuff because I've already got. I'm writing replacement functions that fit under a reasonably complete set of test cases. So I feel much less compelled to do anything about it. But on the other hand, you know, that's a good way to make errors too. So I think my compromise position is I'm going to get things. I'm going to replace them when they seem not too bad, which I think this is one of those. And then I'll backfill tests when we get things when we get the whole thing, the new parser in. I'm going to clean out the old functions we're not using anymore, and then I think as we refactor, we can write those tests, backfill those tests. Again, if I didn't have a good test suite, I wouldn't be having this option. I would have to drive stuff in. All right, so let's see. So we need to break it apart. So let's get token expers equals argument. Okay. Now, so the type thing we don't really get a way around. Okay, so token. What did we access? Name. Where did that come from? It came from variable. Okay. Yeah. Okay. So I guess we got to make sure we got a variable. Okay. So guard case. Let variable of name equal token, else. Okay, this should be a kind of can't happen situation. It's November variable token dot type. It shouldn't be able to happen because I did a match on dot variable, right? So I know it's a variable. I don't know the best way, but let's see. Do we have an error? No. Pattern with associated enum does not match variable. Oh. My tokens, I'm not understanding them well enough. Okay, I guess we pulled out all the types from token type, but wait a minute. That doesn't seem like what we saw up there. Case variable equals token type. Oh, token.string. Okay. Okay, we don't need this then. Name is token string. We'll take this little bit. Okay, we'll compute the type. Okay, name. Okay. If basically token type like left paren, that's the same as saying if our expers is missing. If, well, let's do this. If let expers equals expers, this is a little bit of a an oddity in Swift, but because it's their way of checking if something is nil, and then reassigning it to this variables. They're gonna fix this syntax. I don't think they did yet. Okay, but if it's not nil, then we do stuff. If it is nil, we're gonna return that variable. Okay, so it's this stuff. Okay, so if it's nil, this expression won't get executed and will fall through to this case. If it's not nil, then expers now is the non-nil variant of expers, and we're going to do the other case, array access name type expers. Okay, and I don't know, is that? Oh, we return. And it's awkward. I in a way I'd like to say if it equals nil, then return variable type, else return that. Maybe that's better. I usually try to avoid the bangs where I can, but I've got several here, don't I? If expers equals nil, okay, then we return variable. Otherwise, we'll return array access expers bang. We know it's not nil, so the bang is okay. Okay. Yeah, I think that corresponds semantically to this. Okay. Nullen, hey, good morning, or whenever it is to you. So what we've got is a basic interpreter that was written with recursive descent parser, which is kind of a standard way to write parsers. You're basically matching stuff, and if you see a token, you match it. You need a loop, that's fine. So in this case, we're doing a variable, which is either a variable or an array access. So if you come in with a token being a variable, then you just return it. But if there's a left parenthesis, well, now we're going to go into a loop looking, we'll match an expression. So we call that routine and then write a while loop to dig out the commas, and inside call more expressions. So we're matching expression, comma, expression, 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 and so on. We're replacing that with this new parser library that we wrote more or less last week and the week before, which produces these rules that are much more like a grammar. So we match a variable, and then optionally we match a left paren, expression separated by commas, and right paren. So the operators probably are more or less unfamiliar since I kind of made them up, but they're based on, and or and not kind of stuff, kind of based on the grammars that people write. Usually they put two things one after the other with no operator, but since we're in Swift, we have to be explicit about the operators. So my goal with this is this chunk of new parser code replaces all this stuff with the while loops. Whoops, not quite that far down. But it replaces that body with something that's much more concise, and if you're used to grammars, it's probably more readable. So it also separates the parsing from the semantics. So this version, you can see I'm blending. Here's some semantics. Accumulating expressions is part of the semantics, and returning array access. All that stuff is semantics. I've separated them now, so the semantics, we parse the thing into this, and then the semantics apply. So that's got good and bad to it, but it's I think the good outweighs the bad. This approach is probably a little more costly from a performance kind of view. This one, you can build up just the bare minimum of stuff and kind of accumulate things in small chunks. This one is willing to build up like an array of all your full expression and stuff like that. It's not going to matter in the environment we're in here. And since I'm doing basic, in the old games, it ran like 100 statements a second. We can easily do that. Okay, so the approach I'm taking overall is I'm trying to be evolutionary. So I want to be able to replace one parser at a time, check in anytime, publish it, release it, and go. So we've got these wrappers that wrap the old way of doing it and the new way of doing it. So to make this parser work, we're gonna do a wrap new. So variable parser is the new way. I'm going to wrap new with self and variable parser parse, and it throws and it returns an expression. So it's analogous to this, even though this is the old style, throws, returns expression. The new style has a special structure that it returns, and I should be able to comment out the rest of this code. Okay, and this should make the new parser just do its job. Now, something's not. There we go. Okay. And let's run it. Okay, so let's kill off the old. Okay. Now this, I'm curious who references this. Yeah, there's a bunch. Assignment statement. Comments to variables. I don't know what that is. Okay. So we'll leave this parser as is for now and move on to the next one. Oops, let's get rid of this. Okay, so we're working our way through the factor method. So we've got parenthesized, we've got number. Yeah, I could inline that, but there are multiple places that call it, so I'm not going to. Let's go on to predefined function call. Okay. Now this one, let's see. Where did they come from? Token dot result type. Okay. Predefined function call. This token dot string, token dot result type. Okay. So matching this, function equals type. theoretically that's a can't happen. Okay, I don't think we need to care about it then. We do match a, let's see, what was the word there? Predefined function? Predefined, yeah, this case. Okay, so let's match predefined. And that's the name of a, let's see, predefined function parser equals. The predefined is the name. It's already looked up the name and said, oh, you're the sine function or cosine or something I know about. Okay. So we need the word predefine, the function name, and we need a left parenthesis. Okay, so we'll keep that one, match a left parend. Okay, that's this. I think we'll pull this out. Left parend. And then, expressions, comma, expressions. That's semantics. And a right parend. Okay, so that's very much like this. Well, I probably should put that up here then. Keep left. Match predefined function. So function call, function name, left parend, wrap old expression, match commas, right parend. Okay, that corresponds to all that. We've got to do that. Do the type check and predefined. Okay. Now this could get messy. Okay, so I need a function that does that. Okay, and it takes an argument, and then we have to see what's coming in. Well, we're keeping the predefined, so we get a token. I think it's like the other one, token and array of expressions. Well, in this case, the array of expressions must be present. Okay, and we're trying to produce an expression. And return dot missing for now. Okay. Cannot convert value of token expression. This is where these things are messy. Keep left, keep right, keep left, satisfy, satisfy. Okay, let's see. So in this case, I want to keep the left one. I need that to get my token. This should be ignored because it's got no less than sign by it. This should form a list of expressions. We should keep the left and ignore that. AKA array of expression goes to expression. like it lost the token. Maybe, I don't know if I have a precedence issue. Token expression goes to expression to expected argument type. Match predefined. I'm pretty sure this should... Oh, he's ignoring that. He's got to keep this. Okay. I think... Yeah. And then this... Yeah, there's where my friends go. Match left, match right. Okay, I think that might be better. Predefined will be present. Yeah, there we go. And this gets ignored. Keep the wrap bold expression commas, and that gets ignored. Yeah. Okay. Now, this one's going to be messy. Okay. And the reason it's messy is this thing of blending, checking, and we're doing semantics. We're inserting extra parameters, and we're type checking, and then we're doing something to produce something. Gosh. Well, let's pull out the pieces that we have and see if the rest is easy enough to go with. Okay, so this is the function name. And this one is the result type. Okay. Those are what were passed in to the arguments here. Name and type. Maybe we should call it name and type. Okay. So this is kind of a can't happen. So that's okay. This one gets caught. Appending expressions, that's pretty normal. This is the line that's going to cause me grief. So the problem is, I think the type checking wants to have dot missing for parameters that are excess. And parameter types, where does that come from? Oh, well, that's actually pulling something out. We might be able to make this work. Let's see, type check. Jump to the definition. Okay. So I haven't done much errors in these things yet. Let's see. Let's find it. I think I have a check somewhere. Type check, type check, type check. No. Oh, how do I spell that? It's, Sandbar. Yeah. Yeah. So here we have require float types. Let's see what that looks like. Okay. Right. It returns an int and string if there's a problem. And the int is the token index and the string is the error message. Okay. Let me borrow this. We're not exactly the same, but we're similar. Okay. So I need to do type check. Let's say check predefined call is a check method. Okay. And I'm going to start with just return nil, which says, as far as I know, it's good. Okay. And then here, let's see, ampersand pipe, no. Less than ampersand pipe. Predefined function call. We don't pass that. Okay. Cannot convert a value of expression token expression, aka token array of expression. Yeah, that type is wrong. This should be token array of expression. Okay. Right. And then, so I'm trying to get the basics of it in place and then make predefined function call. That thing's goal, it needs to, it really does need those on the expressions. Okay, so we're going to have to do something like this. And something like this. Okay, so right. So this bit, well, this bit corresponds to our type check here. And this stuff, well, we kind of have to fake that here, but we also have to do it here. Okay, let's see if we can do this one first. Okay, because I don't think it's that bad. Okay, where'd that function thing go? Yeah. I can't do throw. I'm going to return missing, but this is a can't happen case. Okay. Right. All right, let's get the code result type is what's passed out here. Okay. All right, this is going to be the end result no matter what. Okay, so name comes from token string, type equals token result type. I guess we're peeling apart the type. All right, we got this covered. Right. So let actual arguments equals expressions. Did I call it? Okay, peel that apart. The name and the token. Okay, so we peel apart stuff from the token. All right, then we got to do this stuff. Let's make those actual arguments. Dot count is too small. Then append to actual arguments. Token dot string. Bang. Okay. Far. And this is actual arguments. Okay, so I don't need that anymore. Okay. We get the token and the expressions from the argument, the token name, the token type. We verify the type should be a function with parameter types and a result type. We push enough. We start with the expressions we were given. For any missing arguments, we push them on the list, and then we create a new predefined. Okay. I think this is, well, we didn't do this, but I think what should happen if I say return try wrap new of this dot parse, okay, and don't do this stuff. I guess I'm assessing my tests at this point. What? Oh, I'll forget self all the time on here. It will eventually go away. These things. Okay. Yeah. So I think the tests, function call tests that don't have optional arguments should pass. We're constructing the right return value here, as we did before. So I think those will pass, and I think we'll get some failing messages about parameter counts, and we might get a failing message on the missing left parend. I think we can fix that easily, but I think it should catch that. All right, so let's run tests. So I'm expecting failures. If I don't have failures, I definitely have holes in my test suite. Okay. Predefined, that all is promising. Enforces types. Okay, square root of a string doesn't happen. Number of arguments. Left dollar requires more arguments. Okay, no error found because I took out the checking. And then mismatch for multiple arguments. Okay. But that sounds like I missed that left parend case. Test predefined function missing left parent. Oh, this should be a check error. Okay, I think that test will fail. I think it'll get the wrong message. Okay. Missing expected character. Okay, yeah. We have a mechanism to deal with that. So let's find that. There we go. So right parent, left parent. That test should pass again. Okay, cool. All right. So the bulk of what we did is fine. Down there. Predefined function call. Okay. So the parsing is okay. The problem is the check predefined call doesn't really do any checking. So we need to make that happen. And I think, unfortunately, we're going to have to do kind of the same thing here. And I guess that's what it's going to boil down to. Okay, so let's paste that for a reference. Okay, so we get token. Well, we're going to have to do similar to what we did up here, unfortunately. Token experts equals argument, and this stuff, and that. And I want to get rid of the duplication at some point, but I'm not going to sweat it for now. Okay, predefined. All right. What did we do here when that failed? We threw an error. Okay. If something goes that wrong, we need to return index of token and a message. And the message, I usually put a can't happen. Predefined has inconsistent type. Okay. And this is fine. Return nil is not fine. Okay. And then the type check. Okay. So we have parameter types. Let's see where those are coming from. Parameter types coming from here. And we're gonna call type check. Parameter types and actual arguments. Okay. That thing in the row, so we gotta put it in a do catch. Token. I don't think we need it. We do need the message. Okay. Okay, we try the type check. If there's a message, then we're going to return index of token and the message. Well, he returns a token. I guess we can use that. Okay, and then we have the unfortunate no accessible catch. If we get any other errors, well, we still have a token up there, and okay. Yikes. All right. Now, one thing, what I would like to do is let type check handle that count. Oh. Okay, that may be a problem. Okay. Name was never used. Okay. Result type was never used. Right, because we're checking the argument types. If we get down to the bottom and there have been no errors, then we have a successful return. Okay. I think that should pass our test now. All right. Let's see. So I've got some commented lines I should get rid of. Okay. And double check. And commit. Handle predefined function calls. I guess I should say with new parser. I don't know. I'm less happy about this one than I have been about some of the others. Type check is used in a few places, I think. Yeah, a couple. Predefined, and then is this user defined? Yeah. Okay. So I don't know. We'll have to see. All right. We've been going a while. Let's take a break, just like 3 minutes, and we'll come back. And I think user-defined function is the last one in that factor, and then we can start pulling this up into there. All right. See you in about 3 minutes. All right. Welcome back. Okay. So let's handle user-defined function call. That was called up in that factor method. So let's see what token it's starting with. I think it's just user-defined. FN, maybe? Where are you? go. Yes, .fn. Okay. So our parser is parser UDF user defined. Um, we start by matching a .fn, and then we match variable equals token.type. Well, we don't need to look at the word fn, so we'll do an imper that. We do want to see a variable. Let's see. I think we can give an error message to match, maybe? No. This is where my error message may change. If yeah, this. So this list is what do you say when something is missing? And I'm going to say a variable. I want to use the word variable. Missing variable. Variable name. Okay. So I think this call to fnx must have letter. I think it's going to say missing variable name. And I don't like that. Jump back here. I'm going to play with this a little. I'm going to say you can give it a name. A message defaults to missing expected character. A string. If you do that, and you pass a message, I want to use the message. No, I don't think this is what I want. I think I'll make a new one. Saying you must have a message. And then I think this one, I think this is the same as this. Match token type message. Okay, so this should still work. Make sure the tests all pass. No. Okay, what's going on? Missing parentheses. Oh, I didn't put the word missing in there. Oh, right, the message was missing. Message isn't the right name. Missing message. This is token description. Okay. So add message to match. And then if we go back here, okay, match variable. Now I can add my message. Call to function F must have letter after function. Okay, that's fine. Parameter. Then I need a left parenthesis. And an expression. Okay. So I think I'll put all this, the result of all this, the only one that counts is the variable in the middle. And then I want to see well, that's kind of confusing. Let me put the parens here. Keep the left, match. No, they were right before. Okay, now we want to find expressions, which is wrap old self expression, and you're only allowed one expression in these defined ones. Okay, and then I want to keep the left and match a right parend. Okay, and then I'm going to type check this. Oh, and that's one expression. Okay, so cool. And produce. Okay, so what's the matter here? Oh, one too many. Okay. So this parser, it matches function, throws it away, keeps the matched variable, throws away the left parend, matches an expression, and throws away the right parend. Okay. And then we need to do a type check. What do we call it up here? Check user-defined call. And then we need to do a make user-defined call. Oops. Okay, so function check user-defined call, and it's matching a token and an expression, so that's going to be a pair, a tuple. Argument token and expression. We return int string optional and look like this. Okay, so we have the token expression equals argument. Okay, that we checked. Parameter equals token dot string. Oh, we need that for later. We don't need it for the check. The check is really type check, number, and expression. Cache parse error dot error. Let token, let message. I guess we can keep the token here and use it if we need to. If that's the case, then we're going to return index of token and the message. If we get some other error, how did I say it up here? Unexpected. Yeah, let's do this one. Don't think that's true. Okay. Yeah, so the type check, the number expression, type check expects an array. That's fine. If it fails, we return a message, otherwise nil. And if we get an unexpected error there. I'm going to say internal. These are kind of like can't happen. Okay, so I don't have a make user defined, but I think my parser, my check, error, argument, token expression, match, do the type check. Ugh, it's so much overhead to do these. I'm wondering if there's a way to push this into the method. But it'd have to know the parse error stuff, so I don't think so. Maybe. Okay, we'll think about that. Okay, make user defined call. Same arguments. But this one returns an expression. Make user-defined call. Okay, and type matched. Good. All right. Variable that we covered. Parameter equals token.string. We've got the expression. Okay, that's a pretty straightforward one. I like these to be unconditional, like this. Okay. We're not calling it yet, so it should be fine. All right, now let's try wrap new self UDF dot parse. Okay, this is the new. Well, we don't even build. Oh, return that. Should pass. Okay. Take out the comments. Okay, I think this may only show up in one place. Yeah, so let's inline this. Take out this method. CDF parser, take that and put that here. Okay, commit. Make new parser for user defined function call. Okay, so now, well, maybe we should inline this one too. Well, if we do a wrap new let's go down here again. I would really like to inline that. Maybe I'll keep the duplication. Yeah, let's inline it. And we'll use that here. Predefined function call goes to wrap new. Let's make sure that works. Okay, so pull predefined function call into factor parser. Yes, that leaves duplication. I think it'll go away at some point. And we'll push. Okay, so now notice every branch except the last is calling wrap new. So that tells me I should be able to do an OR parser. So the factor parser is, well, it's parenthesized parser or number parser or integer parser or string parser. I don't know. I don't think that's even so bad. I think I could read it in one line like this. Okay. Those or string parser. Oh, we got one more variable. Well, variable is an old style call. Self variable. Oh, he's not. He's got a parameter. Let's hold off on that one. There is no variable parser yet. Okay, predefined function parser. Or user defined function parser. Okay, let's see the case of this variable. That may be, yeah, let's inline that one too. Again, I'm leaving it because there are other places that use it. UDF predefined variable parser. Anyway, there's other places that use it still, so I'm not trying to completely replace it just yet. But in the end, everybody's gonna reference this variable anyway, so it shouldn't matter. All right, let's make sure that's all right. And I left out variable parser up here. Let's do that. Okay. So a factor is either parenthesized expression, number, integer, string, variable, predefined function call, or a user-defined function call. Okay. So all these things, and then we have this error message. Well, we have a special operator for that. I think it works like this. Let's see. Let's get an example. I don't know what we called that thing. It's not a check. It's probably part of this stuff. Or else. No. Name. Right. Yeah. So you do this operator and then the error message. Okay. Where's my... Okay. So this is a string, which is this message. Okay. So each one of these is a new style parser each one of them returns an expression, so they're all compatible. And then I have this name one. So I should be able to say return. I'm still an old style function myself. I have take no parameters and I throw and I return an expression. Okay, so I'm gonna have to wrap it, the whole thing, in a wrap new, but factor parser dot parse, and I probably type a try. Okay, and now I'm saying that replaces all this. Okay. And it should be a neutral change. Okay. Now we get rid of this. Okay, make sure. Make factor a new style parser and push. Okay. Let's see. So now, who calls factor? One place. Good. Okay, there's power parser wrap old factor. Okay, let's inline factor. Now, factor's fairly complicated at this point because it's got all the methods that were underneath it. I guess I can just go back. Okay, so parenthesize parser, number parser. That's, we're kind of going bottom up. There's our factor parser. Now we don't need to wrap old. This is just a factor parser. Okay, and this doesn't exist now. Okay, so let's go back here. Back. Oh, did I totally kill factor? Let's see, factor. Okay, I think this should all be going away. It should be inlined, but I'll just comment it for a second and make sure. And I tend to be doing that more in these replacement things, just to kind of make sure everything's going okay. Nice. Okay. So now factor parser is covered by all this stuff. Okay. Let's go back here, delete this stuff. Okay, we're getting to one of the tricky places, so my anticipation. All right, so we've inlined that, and let's make sure everything's good. Inline factor to expression. Okay, now expression. See the wrap olds, they're all expression. Okay. We need to make expression a new style parser. not sure the best place to do this. I mean, these things really we don't reference them throughout. Okay, let me show you what's involved, because this is the tricky one. Okay, we're forced to confront our recursion. All right, so the way you do this, here's bind for recursion. Okay, so I have a parser expression and a parser that references expression. So what I want to do, because I want expression to reference itself, okay, so if I don't do something, right, I can't define it and use it in the same expression, right? I can't, declare variable x equals x, right? It doesn't make sense. And that's what I would do if I had to say expression equals this. Now, in the grammar rule, we can say that, but in real code, we can't. So the workaround is this bind that basically lets us name the expression here and define it here and then bind it back in, so we use that parser as the expression parser. Okay. The thing I think is true for us, and this is one of those moments where like we've done a lot of mechanical stuff to this point, but I think we're to that dreadful point where you have to start thinking again. I want to define. I want my callers to do the right thing. Okay, and right now, let's find usages. Like we've got multiple usages here. Okay. This is an assignment statement. Okay, you say variable equals value. So you, here's that variable parser again. We would like to define an expression parser and a variable parser and all those, and have them available at the top level. And I feel like there's an issue with doing that. Let's see. Let's try and move these declarations up, at least one of them. Let's get back an expression. Okay, integer parser makes no reference to, I mean, all three of these, they don't make any reference to recursive types or any other types. They just match. They call match. Let's see if I can make this up top. I don't think I can. I think I got an issue around instance methods and stuff like that. But I would like to have a function definition like that. Now, is that allowed? Not happy. Instance match with property. Yeah. Okay. We don't have an init on this class. Let's try it with an init. I think we're going to run into the same issue, but let's give it a shot. Okay, take the let off and let number parser. Oh, what's his type? Yeah, thanks. Let's do this. Let number parser. This is unfortunate. All right. Let's. I don't think this is going to go any better. His type is this. Okay. And we take the let off. Is that still unhappy? Type is ambiguous, cannot specialize, remove, satisfy. Yeah, I don't think that's going to help you. Yeah, okay. Yeah, I don't think that's going to work. All right, let's go back to expression. We're going to see someone that calls it soon, right? Define. Expression. Okay. I would like to make the thing is I want all these parsers. Okay. Let's extract a method called expression parser. Okay, so it's going to give me parser. I don't think it needs anything, but it's going to give me, what the heck is it going to give me? I really just want to say this and maybe fill in a couple types, but it won't let me. So I think I can say this. Bind. Let's go back here. Okay. Int here is the input type, and array event is the output type. Okay, so this is a bind. Input type is token. Output type is expression. Not too horrible. Okay, so what I would like is I want to return the whole expression parser. And we're going to do it exactly like this. Well, exactly. Being a loose. Okay. Let's say result. Bind. And we're going to match token. Expression. And in the end, we return result. Okay. Now, let's get this stuff. Okay, so we're going to build a parser and call expert.bind parser.parse. That parser.parse is the parse function. Expert.bind parser.parse. And we're going to say let parser. Well, we're going to say a lot of stuff. We're going to say all this stuff. Okay. Factor, power, negation. We want to get down to OR parser. Bool OR parser is our top level parser. This is result.bind and return result. Okay. I think this gives us a properly recursive, and I'm going to call it expert parser. Sorry. Expert parser gives us all that stuff. And let's call it expression. Oops. I'll work on the names. Okay. Yeah. So this now, I'm going to make this just be expression. So this is how I can reference expression because I've done a bind already. Okay, there should be some more of these. Yep, getting rid of all these wrap olds. Okay, in the end, if we have no wrap olds, we've made a big step. We're going to have some still, but I believe we're getting there. Okay. More wrap olds? No. Okay. So let's make this I think I can name it expression parser. I hope so. Expression parser. He's not going to complain the function name is the same. Okay, good. All right. So now I have an expression parser. It's a new style parser. I should, if I want to handle expression, I should be able to say wrap new expression parser with self dot parse, and I do a try on that and that and return that. Okay. If I've done this right, it may not be ideal, but why I say not ideal is because I'm rebuilding these grammar rules every time I call this, but I think I can get around that. All right. So this should just work. It feels like a biggish step, but I think it should just be a neutral transformation. Oh, good old predefined. Expected start of expression. Okay. This is, yeah, so it's coming. All right. What? Okay. These. So what happens? Expected start of expression is when you had this token. Well, okay. Here's the deal. When we may be doing something wrong in the error handling. What happens is I don't want to say this. When it does that percent bracket thing, it's saying I've got A or B or C and then percent bracket this. Okay. What it does is it runs all those parsers and it figures out which one got the furthest. And if none of them got past 0, it just uses the default message. Okay. That suggests to me that this failure, like the failure is you passed a string. Like syntactically, it just knows function I parenthesis expression blah blah blah. So it seemed like it got to the end of the tokens. Now, what I don't understand is why this change we made affects that. Okay, so factor parser. And maybe something in the check functions. Well, it's predefined as the big one. Def call, what's that one? That's a user defined call. Okay. Let's take numeric. Why would that change? All right, let's put this back. Okay, I'm gonna comment out the new way and then put these back. Wow. Okay. I'm puzzled. Cuz I sure thought, well, let's take a smaller step. Let expression parser equal bool or parser. Wrap new self. This shouldn't matter. Well, I warned you this was the tricky one. Wrap new or parser. Let's Okay, predefined function parser seemed to be the one that was messing up the most. Trying to find a smaller step that will do something for us. But I have my suspicions on check predefined call. Maybe let's see how it behaves. Okay, the target token here is the function name. this token. Let's see type check. See, the funny thing is, when you get to these check methods, you've parsed the whole thing. I mean, the thing it's checking on, so that whole function call is correct. And I would have thought token at this point would be like after at the end of the statement, you know. Now it'd be nice if it was intermediate things for the intermediate parameters or whatever, but we don't have tokens anymore for those. So here token is the late thing. I don't know. Maybe that thing shouldn't return. Let's see what the check does. I mean, this is my made up way of doing things, but maybe it's not ideal here. He's a parser. So his result. So he runs the first parser. So the location message comes, the location comes from the check. And in a way, it's nice if I can get the location more specific. Oh boy. Right. So, okay. So it's whatever the check message says the location is. And something's going on with the tokens at this point. I think there's an interaction. It's something about the wrappers, I think, that's maybe creating the issue. It Okay, what? All right, let me try a different approach. Keep saying that. I'm going to try making a bind parser. I'm going to bind the parser in the other method. Okay, so let's bind it here. Bind token expression. Okay, and then down here we need to do the actual bind. So expression parser.bind bool or parser.parse, right? I think that's what we did up here. Expression parser, okay. Expression bind bool or parser.parse, and we returned it. Okay, let's just call it. Still wrapped. Okay. Return, try, wrap, new. Oh, I think that's okay. Wrap new self-expression parse. Okay, but the difference is I've still got expression refers to a wrap old. Okay, let's see if this works. Okay. Now, so according to that, if I put well, how do I get them? I guess if I put expression parser here, I think this will make it fail like we saw. The function, okay. Yeah, this is user-defined function. Okay, and the error is the problem is I don't know how far it gets in the check user-defined call, right? I'm taking the token. Let's go back. User-defined call. So the token is the variable. So, gosh, you would think that would be... let's break in there. I guess nothing's interesting till there. Okay, and go back. I'm going to put expression parser again. Well, yeah. Okay. I want to see what it looks like in there. So I'm going to run it. Let's run the one test. Where was that? Parser test, define function. Yeah, this test. Okay, so let's see. Token is variable I. So this is function I of string. So I don't know why this is not at least one. Well, it's more than one. It's going to be, we have 0, 1, 2, 3. It should be index 3, I think. Okay, so that says we have this token and we are just marking a failure. Function type mismatch. I don't think that's the best place to report the error, but that's what we got. I've got a theory on doing better, but this is the starting point. Okay, but this index 3, that's pretty darn good, right? It's better than 2 anyway, which is what I think that name thing should get. Okay, so can I break in there? name parse. We're calling the left-hand parser. Okay, we haven't gotten here yet then, I don't think. Okay, so let's continue. Okay, and we'll step over. And let's look at location. Oh, we can see it's 2. And input.start index 2. Okay, if location is greater than that, well, wait a minute. Why is location 2 and not 3? Index of token was 3. We should have a specific message, but it came back 2. Failure start index default message. Okay, so the default message is the one you got passed in, right? That seems reasonable. Okay, so somehow we got as far as the 3. Maybe it's the OR that's not doing the right thing. That's this best failure thing. Okay. How can I do a better test? Okay, this best failure thing is I ran both parsers. If they both succeeded, I return the result of no. If either of them succeeds, I return its result. Otherwise, my result is a failure. And I'm going to get location 1 and wait a minute. Somebody should be looking less than something. Oh. If failure 1 is location 1, oh, those are more can't happen things. Okay. If I don't have a failure, then something went wrong. Okay. If location 1 greater than location 2, return failure 1 or failure 2. So what this to me says it's doing, if I have 2 conditions, A or B, and A fail, they both fail. If the first one got further, I want to take its failure. If the second one is the same, if they got the same, I'll take the second one. And I think that looks right to me. Okay. But notice here, we definitely had an index of 3. And yet when we came down to the name defaulter thing, it said 2. Excuse me, which says nobody got anywhere because 2 was the start of our tokens. I don't know if we can see there's the input. 2 is function. So yeah, we were calling function I of a string. So 2 is the start of that stuff. Before that was 10 print. Okay. So I guess we'll look at this. I'm going to trim down. Okay. I don't like doing this, but I don't see a way around it. A good way to test this stuff around it. Yeah. User defined function. Let's take out let's take out okay, I'm going to modify factor parser. All right. Okay. So factor parser, I'm going to take out parenthesize because I don't need that. I don't need that. I don't need that. I do need string parser because that's the argument. And I don't need user defined parser. Okay, so I'm saying the only two expression types you have are strings and predefined functions. And if you look at our test, it has a predefined function. Oh no, that's a user defined and a string. Okay, so let's make that user defined. That. Okay, so it's going to try and match it as a string. It's going to fail, and then it's going to say, okay, let me try it as a function. Okay, so let's do this again. We got a few more breakpoints and less to look at, I hope. Okay, so now location 1 is 6. Six? Where's that coming from? I don't know if I can see the tokens. Yeah, there's the input. 3 values. Okay, print input. Whoops. Input. Okay. 6, 7, 8. Right parent. I don't get it. Failure. Expected character. Expected character. This test is not missing a right parent. Am I running the right test? 6, 7, 8, 0, 1, 2, 3, 4, 5, 6. What's going on? Function call must take numeric argument. Can we tell what our parsers are? Not really. Missing expected character. It's almost like it doesn't parse the string. All right, I'm going to continue. Missing expected character. Do a type check. Okay. Well, token is I. I'm not quite on top of it yet. Okay, but okay, the token, this is type check. Okay. Now it should get an error message. Yeah. All right. So let's look at token. Well, it's over there. It's I. No. Column 7. Oh. Index of token is 2. So our type check failed. And it returned a 2. And 2 is the function. Okay, so let's see, type check. Why is token FN? Okay, yeah, so this is probably something in the wrapping, like the intermediate states or something. When we're wrapping a parser, we kind of act like the new style parsers don't adjust the token position until the end, but they might be further along. Um, I'm not sure what to do here. So the problem is, okay, so if we're in a new parser and we call type check, it thinks token. Yeah, so the new parser, I mean the new style parsers, they have a slice of the input, and then if they succeed, they move forward in the slice. The old style input, it moves forward token by token as it matches. So if it got to this point in the old style parser, that token would be the correct one. Well, it'd be more like the end of the line or something. So it would be further than slot 2. But because it's unadjusted, the token here is the function. I don't know if All right, let's look at our parser wrappers, adapters. Okay, the interesting thing on wrap new. Okay, we parse the ... says make a slice, and if it fails, we what does that do? Parse. If it fails, we throw a message. Interesting. Wrap old now. I know it keeps track of the index. Yeah, see, wrap hold, it resets this index because how's that working? All right. If there's an error, it resets the index back to where it started. Does that make sense? Well, I'm trying to figure if a wrap old is doing anything. I mean, I think that's what's going on here. I think wrap old is very careful to put the index back where it started here. Let me see. We're given a slice. We're going to say this thing should start reading here. We try the old parser. The old parser might move the token forward, but the new style parser wants the index restored back to the original place. So when the new style parser fails, it doesn't move the index forward. All right. So I think that's the piece that's making this happen. If the new style parser fails, we report the error at the starting index. Is that right? So resetting index here. Oh, wait, where's token coming from? It's coming from the error. Okay, so if the old style parser fails, we get the token, which presumably is however far it got in the parsing. And then we put this index back, but we're still using the token from the error message. Okay, now the new style one, when it gets a failure, we have failure index. Well, this seems somewhat okay. Okay, let's say we parse starting at position 2, we get to position 3, and we fail. We should mark failure index 3 and get a message, which appears to be what we did here. I don't know where we are in our code. I don't think I'm in scope. Yeah, okay. I don't know why that. It's not really quite accurate for where we are. Where's my debug view? Let's see, let's check. Okay, token, we decided is still at the FN. That just seems wrong. Token type is the FN. Okay, let's go back here. User-defined function parser. That's the one we're on. FN. We match the FN. I don't even want to keep the FN. And then we match the variable. I would have thought this should be the token, the current token coming in here. That tells me something is wrong with my understanding in a big way. Okay, so I would have thought you'd get the variable and the expression. Throw away that. Okay, and we're going to keep that left. Maybe this is why is token that? Token, print argument. Oh. Whoa, wait, what? Oh, I've got my axes are named the same. Okay. Okay. All right, let's go see what this is. Jump to definition. I would have thought this would define a local variable. I'm sorry, we are at this line. This token comes from the error. So this jump to definition should be 2 lines up. Okay. That token from the error of the type checker. Okay, I'm getting there. So the type checker down here somewhere. Well, let's jump to it. This, when he throws the error, he takes token, which is the still back at the function. Yeah, this token thing is not good. All right, let's see. Type check. Check predefined call. Type check is my function here. Who else calls this? There were a few. And just these two. Okay, I'm gonna... Let's double check this one. I'm gonna say we gotta pass the token in as well as this. I don't think it's ideal. Okay, but I think we need it. Because the token we're getting from here is the global token. It's not the current token that we have here. That's what it comes down to. Okay. Let's put that in, and then I'm going to call it lunch for me. And then I hope to come back in an hour and a half. Okay, so this token, I'm saying type check is going to take a token. And they both have well, this is the predefined function call. All right, I'm going to pass that one too. It may not, and it may not work. I may fix one and not the other, I'm afraid. And you can't find it now because, okay, type check. Let's take a token of token and that. And then the error we return back comes from token. Okay, let's run this test. That should fix this test. Okay, now these others, we're going to have to put our syntax analyzer back. Find expression. Okay, let's put this back. These I'm not so confident in because I have a fear that the token hasn't moved forward yet. Okay, so I believe I'll get 3 failures. We'll see. Yep, so predefines. Okay, well, I gotta stop. Like I said, I expect to be back in an hour and a half for another session, and we'll track this down. I don't know. I'm gonna have to find some way to convince it to move forward. I think the real longer term solution is that expressions should know their locations. They don't. Location is such a tricky thing too. But it would be nice to know the token that started an expression. Yeah, maybe these could keep their tokens. I don't know. We'll work it out. All right. But anyway, thanks for joining so far. I'm off tomorrow, but I'll be back Monday at the normal time, 10 a.m. Eastern or 3 p.m. UTC. Like I said, I'm going to do an extra session this afternoon, barring any problems here at home. And we'll try and get through the debugging on this and hopefully finish expressions. Yeah, errors the stuff that kill you in compilers, I tell you. All right. Anyway, thanks for joining. Take care. Bye-bye.